All right, since I know Tree is finally awake today, and he's not on the phone during this class, are we ready? Is Tree ready? Tree is ready. All right, so now, do me a favor. Pretend like you want to be here. Pretend like you want to be excited about this. Okay, you ready? Are you ready now? Are you ready? Okay, you ready? Hold on. So I don't want this to, like, weren't you squirting out your nose while we're doing this? Because you're just that excited, okay?
Yeah.
You done? You good? All right, class.
Yes.
Thank you. That's a lot better. Okay. Yesterday was not very good because Tree, hasn't slept in 84 hours. But today is good. He had a good nap, right? Okay. All right. Final limit. Limits fractional powers. Now, I have a very, I call it specific view of these. I don't know if you guys actually had the same explanation. A fractional power, so if I have x to the a over b, a is the power and b is the root. I don't know if it's ever explained to you like that, but that's what it is. So the top number is going to be the exponent, where the bottom number is going to be a root. So you could break it up into two separate parts and work it out like that. So we could do that with each item of the entire limit. So what this is saying here is I'm going to take the limit and then do the exponent. So if I have it like this, I would just find the limit first and then raise it to that exponent. That's important. That's a good rule right there for you. All right, let's plug in. Let's evaluate. Bless you. Let's evaluate for this one right here. So as x approaches 8, that's going to be 8 plus 1 is 9, right? Okay, so if I'm doing this, that's going to be 9 raised to the 3 over 2, which is same as saying the square root of 9 raised to the third. So I could do it like this, or I could also do it like this. With order of operations, it's whichever comes first. But because if you're multiplying something by a fraction, you could do either the top number or the bottom. You could do the multiplication or the division. In this case, I could do either the power or the root. It's happening at the same time, so you could choose which one's going to be easier. Do I want to take 9 to the third power first? I don't remember. Tree, you know your nines? What's
729?
That's 729? Okay, so I don't know those. But what I do know is square roots. So make the number smaller first and then take that. So that's going to be, what's the square root of 9? Square root of 9 is 3. So that's going to be 3 raised to the third, which is going to give me 27. And did you know that the square root of 729 is 27? No, it's not things I actually try to remember. But if you know that 9 to the third power is going to give me this, and then break it down, so similar. Makes sense, possibly. Anyway, let's keep going. Find the limit of a polynomial. Basically, just plug it in. Plug it in and replace x with c. That's important. Replace x with c. Evaluate this at that point. Okay. Evaluate this. Now, I'm going to look for a couple things, especially when I'm doing limits, is there any place in which that this is going to be undefined? Is there any domain restrictions? This polynomial, okay, simple polynomial, right? It's an x squared. I don't have any place in which that it's going to divide by 0, right? When I evaluate it, I am not going to get a divide by 0 error. Is there any restrictions like a square root? A square root in which that it's going to give me imaginary numbers? No. Okay? We're looking at both of them. Neither of them is going to do that. So I could just evaluate by plugging in my numbers. So that's going to be 4 times 9 minus 3 plus 2. 36 minus 3 is 33 plus 2, 34. Is that correct? I'm hoping. Okay, I'm not very good at math, so that's why I need you guys to actually like double check all my work. It's 35? Okay. Because 36 minus 3? 33, right? There you go. Always check the work. Sometimes I'll actually make these mistakes on purpose to see if they're actually even awake and following along. Other times I just make a mistake. So, next one, evaluate the next one. So, this is going to be -1 to the 5th power. What is -1 to the 5th power? -1 plus 4 times -1 to the 3rd power. -1 minus 2, -1 squared, +1. So I'm going to get -5 minus 4 minus 2. What's wrong? Did I mess up?
7.
7?
You put 5 times -5.
Oh, you're right. So that makes this other one. It's a weird software thing where it's not actually still not used to the new little thing on it now. Anyway, is that math correct now? Yeah. So what do we end up with? -13. Make sense so far? Okay. Find the limit of a quotient. Quotient is a fraction. It is a dividing. So if the limit exists, and in that limit, the denominator can't be 0, cannot be equal to 0 because that would make it undefined, I could take my limit, separate it into 2 separate limits, and then evaluate it at that point. Make sense? Hopefully? Good? All right. Find the limit of an average rate of change. Now, you guys should have seen this thing before, which is delta y divided by delta x, which means the change in y over the change in x as we read it from left to right. When we're looking at our math, we're normally looking at it from left to right. So as we're reading it, it is up and down. So the delta y is up and down, divided by x, reading it from left to right. This is a basic way of looking at it. Could I do it backwards also? I could, but then I would have to be very careful about the signs that go along with it, because it would be going down. So if I had a positive slope, it'd be going down as I go backwards left. So that's important. So f of b minus f of a over b minus a, which is just y2 minus y1 over x2 minus x1. Same slope formula. Find the average rate of change from 2 to x. From 2 to x. From 2 to x. Now, plug it into that previous formula that we had there. All right, I'm writing this out now. So using the previous formula, which is here, f of b minus f of a over b minus a. F of b, so that's going to be my f of x minus f of 2 over x minus 2. Is it, hopefully you have something like this, right?
Is it not from 2 to x?
Huh?
Is it not from 2 to x? Is it not from 2 to x and not x to 2?
From 2 to x. That means it's starting at 2 and it's going to x.
Okay.
So this is from my a to b, so it's f of b minus a. Because if it was going from x to 2, that would mean that it is going to go this way. It would mean that that x would be less than 2, right? But if it's going from 2 to x, it is above that. There we go, a little bit better. So f of x, so that's going to be my x squared plus 3x, and f of 2, so this is going to be minus f of 2. So I plug in 2, that's going to be 4 plus 6, 10, over. Now, do you understand why x cannot equal 2 here? Yeah, have 0 in the denominator. I don't want that. Now, when I see a problem like that, I look at it and I'm like, man, I'm about ready to drop an F-bomb. Say, F that. Can you factor that? Yeah. See what I did there? See what I did? F, factor, math joke. Okay. So what do we get there? So to get negative 10, but add together to be positive 3, that would be positive 5, negative 2? Maybe?
Yeah.
Ah! What is that? It's weird. There you go. Are we still okay? Now, what can we do there? I can cross out the x minus 2. Now, what was the word I used if I cross it out? It's a hole. It's a hole. So I graph this. It's going to look like a straight line. It's going to look like a graph of the line x plus 5. But because this and this cancel out, it means that the function still has a denominator of x minus 2. It's going to exist everywhere but that one single spot where it would be undefined. So that's why that is going to give me a hole. So now that I have that canceled out, I can say that the rate of change, so my delta y over delta x, so the slope of the line as it is approaching 2 is going to be 7. So we use the limit process here to just find the slope of a line. Calculus 1, is almost all finding the slope. It's just different uses or where I'm getting the slope from. So if I have distance over time, what is distance over time? That's velocity, right? Okay. Now, so if I have distance over time, that is my speed, my velocity there. But now if I look closer at the velocity, and now if I take the slope of the velocity line, the slope, that's going to be the rate of change. How is the speed changing? So is the speed constant? Is the speed increasing, decreasing? What is the speed doing? So if I'm looking at the slope of the velocity, that would give me acceleration, which is the slope of the velocity. And if I'm looking at that one, the slope of that line right there, that one's going to be the next derivative off of that would be the jerk. The instantaneous force in which that it is either increasing or decreasing, is slowing down or increasing at that certain point, and that's of the acceleration. So you're accelerating, so you're driving through that school zone doing 45 miles an hour, okay? You put your foot down to go faster, right? Because you see a screaming speed bump, and then when you put your foot down, that instantaneous, right there, jerk of going, because you got a big engine in your car, and just boom, yes.
Isn't that just the definition of it?
Yeah. That's all this is. And that's all what calculus is. Calculus 1 is we're finding the slopes on all these things. The rates of change is all this. So I just boiled down all of calculus 1 into finding the slope. That's it. So, all right, same thing here, but this one is going to be slightly different, but it means the exact same thing. This is using the difference quotient. So, if I was to have a graph, and I say that this right here is x, and this is going to be h. And I have this point right here, and I have this point right here. And I'm looking at these two here. So given these 2 points, this is, if I don't know what x is, but I know that h is going to be adding to x, right? It's going to be adding to x, so it's going to be increasing that. So this value right here is going to be f of x plus h. That's going to be my f of x plus h. And this one right here would just be f of x. So I actually have coordinates for each one of those. So this coordinate here, my coordinate for A, so if I call this one coordinate A, and I call this one coordinate B, my coordinate A is located at x, comma, f of x. Coordinate B is located at x plus h, whatever that value is going to be, comma, f of x plus h.
Is it coordinate B just H?
No. You're going from here that way, some amount. But you also don't know where x is either. X is somewhere on your graph. Some location on the graph. And we're going to do that same slope formula that we just did using these two right here. So it's f of x plus h minus f of x over x plus h minus x. I'm just plugging it into the slope formula. I know it looks crazy, but I'm just plugging in the function into the slope formula. So what's going to happen here now? X's cancel on the bottom, so I'm left with just my f of x plus h minus f of x over h. Isn't that what this said? So this is just the slope formula again, but they simplified it a little bit. Does that make sense? So it's the same thing again, the slope formula one more time. Now, I want you to do the same thing, but now we have functions for this. And I want you to try this right here. Plug this in to right here. And this is an evaluation. This is important when we're doing this. Because this algebra is where a lot of people screw up. what are you evaluating for the first function, for the first one? Okay, so what does this right here say?
X plus H.
So what does this mean right inside there? If it says f of x plus h, what are you doing with x plus h? You're plugging them in. You're plugging them in for every place in which that you have an x value. So I'm going to go to a new page, and I have 2x squared, 2x squared minus 3x plus 1. And so my function says f of x plus h minus f of x. So that means that everywhere that I find an x, I'm going to plug in x plus h, right? So this is going to be, change the color, 2 parentheses x plus h close squared minus 3 x plus h close plus 1. This minus, I'm going to open a parentheses. This is what I said about the algebra right here. So minus parentheses, and that just says f of x. So I'm just going to rewrite that. So 2x squared minus 3x plus 1. That's what all of that part is. Let's expand this. So if I expand that one right here, this is going to be 2 parentheses x squared plus 2xh plus h squared closed minus 3x minus 3h plus 1, and then bringing all this down, minus 2x squared minus, oh, that's a plus 3x and minus 1. That's an x right. Come on. There we go. Does that make sense, or is that nonsense? Because did I just go super crazy here? Okay, I'm just evaluating. This is what I said about the algebra part right here. I have to understand what is getting plugged in. Now I need to expand it. Now I'm going to go through, and I still have to distribute my 2, right? Got to distribute my 2 and then combine like terms. So distribute the 2. I'm going to have 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 1. And I'm going to keep to the pattern of my blue over here. Minus 2x squared plus 3x minus 1. Now, I'm going to go through and combine. So I have my x squareds go away. Okay, what else do I have go away? My plus 1, my minus 1 go away. I have my minus 3x plus 3x. Those go away. And now I could rewrite this with what's left over. So I'm left with 2h squared plus 4xh minus 3h. And now that's all the top part of this. That's all the top part of this, right? So from my previous problem, that is all the top part of this. And it's still, all this is going to be over h. Now I'm going to write that as over h. Now, this is the key to doing this problem every single time. Get to this point right here. Is there a common factor in the numerator? H. That's important. That's where I wanted to get to. I need to actually be able to factor out an h from the numerator so I could cancel the denominator. So as I do that, I'm going to get h quantity 2h h plus 4x minus 3 all over h. My h is canceled. And this is going to be my limit process for this, because as h goes to 0, that's what I'm doing right here, as h, find the limit as h approaches 0. So can I plug in 0 now? I can, because I canceled out my h, right? I canceled out the h in the numerator, so now I can plug in 0. So I can plug in 0 for this, so it's going to look like this. So it's going to be, let me see, 2h plus 4x minus 3. Is it minus? No, plus 4x minus 3. And now if I can take this as h approaches 0, plug in 0, this is going to give me 0, and this is going to be plus 4x minus 3. So as h approaches 0, this is just going to give me the equation of the slope at any point. That's some good stuff right there. I don't care who you are right there. Make sense or nonsense?
Makes sense.
So when you actually go through and start doing this, this is your friend. This is going to be your friend. And when we find the equation of the slope at any point on x, I can now plug into here to give me the slope at that point. And that's it. So long, farewell. I don't know the other part. Anyway, all right, make sure you all like, share, and subscribe, especially if you're not in this classroom right now. Hint, hint. Okay, watch this video, give me a thumbs up, okay, and share. If there is 200 likes on this video, I don't know, extra credit somewhere.